Hello friends, welcome to Learner's Planet. Friends, this is our third session for progressions. We are discussing arithmetic progressions, geometric progressions and harmonic progressions. In the first session we have already discussed the formulae, basic definitions, concepts of all these three progressions. In the previous session we discussed some basic problems. In this session we are going to take some more problems. So let's get ready. Just have your paper and pen with you and just start solving the problems right with me. Okay. Now let's see this problem. Sum of first 5 terms of an AP is 1/4 of the sum of next 5 terms. If the first term is 2, then the common difference is. So sum of the first 5 terms of an AP will be 5 by 2. 2a. A is 2 over here. So 4 plus 5 minus 1, that is 4 into d. Okay, so that is 2 plus 2d, or we can say 10 plus 10d. That is the sum of first 5 terms. Similarly, we can find out sum of first 10 terms. So that is 10 by 2, 2a, that is 4, plus 10 minus 1, that is 9d. So that is sum of 10 terms is 2 fours are 8 plus 18d, right? But the relationship that is given over here is that sum of 5 terms is 1/4 of sum of next 5 terms. So if we want to find out the sum of next 5 terms, because in this sum till 10 terms it is also included, but we want the sum of next 5 terms, right? So sum of next 5 terms will be what? From this we'll deduct this, right? So I'm sorry, I have done calculation mistake over here. It's 5. So 5 into 4, 20 plus 45d. So from this 20 minus 10, 10, 45 minus 10, 10 is 35d. Now this data is actually 1/4 of this, right? Or we can say this is 4 times this. So 10 plus 35d is 4 times d. 4 times this. Okay. So it's 5d is equal to minus 30. That means d is equal to minus 6. Okay. So this is the correct option. Okay. I hope you are clear. Now sum of first 4 terms of an AP is 56, sum of last 4 terms is 112. If the first term is 11, then the number of terms is. Okay, so first 4 terms is 56 sum. So sum of first 4 terms will be given by 4 by 2, that is 2. 2a, that is 22, plus n minus 1, that is 3. D is equal to 56. Okay, so 3d is equal to 6, so d is equal to 2. Now sum of last 4 terms. So now that will be, the last term will be, or we can say nth term will be a plus n minus 1 d. The previous term will be a plus n minus 2d, a plus n minus 3d and a plus n minus 4d, right? So these are the last 4 last terms. Okay, so they will sum up to 4a plus n minus 1 plus n minus 2 plus n minus 3 plus n minus 4, so that is 4n minus 10. Okay, minus 1, minus 2, minus 3, minus 4, minus 10, and it is d. D is actually 2, and that is 112. A is 11, so it is 44. So that is 68, 34. 4n is equal to 44. That means n is equal to 11. Okay. I hope you are getting it. The value of n for which this is arithmetic mean between a and b is, so precisely this is what a plus b by 2, right? Arithmetic mean between a and b is a plus b by 2 is a raised to n plus 1 plus b raised to n plus 1 upon a raised to n plus b raised to n, right? Now instead of solving this equation, what you can do is, what you want is here, instead of n plus 1 you want 1, Instead of n plus 1, you want 1. So if I put n is equal to 0, what I'll be getting is a plus b by 2, right? So if I put n is equal to 0, left hand side and right hand side is same. That means n is equal to 0, right? So do not solve this equation. Do not go for cross multiplication, and that will be really lengthy method. Okay. Now this problem, the ratio of first to the last of n AMs between 5 and 35 is 1:4. What is the value of n? So precisely this is an arithmetic progression. The first term is 5 and last term is 35. We are inserting n arithmetic means, right? 1, 2, 3 till that is nth arithmetic mean, or I can say maybe an, right? That is nth arithmetic mean. So it is n arithmetic mean between 5 and 35. So total number of terms will be n plus 2. Okay. Now what it is saying over here, the ratio of first to last of arithmetic mean. Now first arithmetic, if we assume the common difference is d, so the next term over here will be 5 plus d. So that is actually first arithmetic mean, 5 plus d. And this is the last arithmetic mean, and we can say n plus 1th term of this sequence. N plus 1th term will be a plus n plus 1 minus 1, so that is n into d, right? And ratio is given to us as 1/4. And 35 is already given to us as the n plus 2th term. So 5 plus n plus 2 minus 1, that is n plus 1 into d is 35, right? That is already given to us. So n d plus d is 30. Now we go for cross multiplication. 20 plus 4d is equal to 5 plus nd. Nd is equal to 30 minus d. Okay, so 5d is equal to 30 plus 5 minus 20, or we can say 30 minus 20, 10 plus 5, 15. So d is equal to 3. I put d, value of d over here, so I'll be able to get the value of n. So 3n plus 3 is equal to 30. That means 3n is equal to 27. That means n is equal to 9. Okay. Now this problem, if C is the harmonic mean between A and B, then C by A plus C by B is equal to. Now what is the harmonic mean between A and B? That's actually 2AB upon A plus B, that we have already learnt in our first session, and that's actually C. Now C by A plus C by B is what? C A plus B upon AB, right? If we take C as common and take LCM, then we'll be getting C A plus B upon AB. So C A plus B upon AB will be actually equal to 2. So this expression is equal to 2. Pretty simple. Now if ABC are in GP, then what you can do is, to make the problem simple, you just take the comfortable values of ABC when they are in GP. I assume it to be say 8, 4 and 2, right? 8, 4, 2 2s are 4, 4 2s are 8. So A minus B, that's 4, B minus C, that's 2, that's not 1, so that's incorrect. A minus B 4, B minus C 2, and that's actually 2, that is A by B, so 8 by 4, so this is correct. Okay, no need to worry about the remaining options, it's correct. Okay, because A minus B by B minus C, what you are getting is A by B, so it cannot be A by C, it cannot be B by A. Left hand side portion is same in all these 4 cases. Now x, 2x plus 2, 3x plus 3 are in GP, then the 4th term. Okay, if these 3 terms are in GP, then the square of the middle term will be equal to product of first and third term. So 4x plus 1 whole square is equal to x into 3x plus 1. Okay, I take x plus 1 as common, So x plus 1 is equal to 0. So x plus 1, x is equal to minus 1. And the other is 4x plus 4 is equal to 3x. That means x is equal to minus 4. So I put x is equal to minus 4. I'll be getting this minus 4 minus 8 plus 2 minus 6. And then this is minus 12 plus 3 minus 9. Now we have to find out the fourth term. See, in AP, I assume the fourth term is suppose say P. Now in AP, in GP, I'm sorry, these three terms are also in geometric progression, right? These three terms are also in geometric progression, that is minus 4, minus 6 and minus 9. Now what is happening? Minus 6 square will be 36, that is product of minus 4 and minus 9. Similarly, these three terms are in GP, that means product of this and this will be equal to square of the middle term. So P minus 6P is actually 81. So P is 81 by 6 in negative. Okay, so that's minus 13.5. Okay, now the eighth term of GP is 128 and common ratio is 2, then product of first 5 terms. Okay, eighth term will be AR7, where A is the first term, R is the common ratio, and that is 128. Now R is actually 2 raised to 7. R is actually 2 and 128 is 2 raised to 7. And R is 2. So 2 raised to 7, 2 raised to 7, that means A is equal to 1. Now product of first 5 terms. First 5 terms will be A into AR square into AR cube into AR 4. Right? So since A is 1, we don't have to consider it. So R is equal to, R is to 1 plus 2 plus 3 plus 4. That's R is to 10. And R is actually 2. So product of first 5 terms be 2 raised to 10, or we can say 4 raised to 5. Okay. Third term of GP is 3. Third term is basically AR square. That's 3. Product of its first 5 terms. Product of first 5 terms is A into AR square into AR cube into AR raised to 4. So that is actually A raised to 5, R raised to 10. Right, so that is actually AR square raised to 5. Now AR square we know that's 3, so AR square raised to 5 will be 3 raised to 5, right? 3 raised to 5 is 243. Okay, first and second terms of a GP are this and this. If eighth term is this, then T is equal to. Okay, so this is the first term A and this is the second term AR and this is AR7. Okay, so AR, that is x raised to T, is equal to x raised to minus 4 into R. So R is equal to x raised to T plus 4. Okay, and AR7, A is x raised to minus 4 into R raised to 7 is equal to x raised to 52. So R raised to 7 is equal to 52. R raised to 56, x raised to 56, I'm sorry. So if I take 7th root, R will be x raised to 8. Okay, so R is actually x raised to 8. That means T plus 4 is equal to 8. That means T is equal to 4. Okay, now let's see this problem. Log 2 to the base 3, log 2 to the base 6 and log 2 to the base 12 are in AP, GP or HP. See, to be able to solve this sort of problems, you must be clear with the basics of logarithm. Okay, now you must be knowing that log 2 to the base 3 is 1 upon log 3 to the base 2. Okay, so what I do is I just write down their reciprocals. That means log 3 to the base 2 is equal to 1 upon log 2 to the base 3. Now I assume these 3 to be in AP, right? If these 3 are in AP, then 1 upon log 3, log 2 to the base 3, 1 upon log 2 to the base 6 and 1 upon log 2 to the base 12. These 3 will be in HP, right? If these three are in AP, then their reciprocals will be in HP. Now log 2 to the base 3 can be written as 1 upon log 3 to the base 2. Okay, so 1 upon log 2, if this goes over here, it will go over here. So 1 by log 2 to the base 3 can be written as log 3 to the base 2. Similarly, right, I started these three to be in AP. If these three are in AP, then reciprocal of these three will be in HP. Now these three can be written as like this, and these three are in HP. Now we can see over here that this plus this by 2 is this. Right? That means these three are actually in AP. If these three are in AP, this and this is same. Right? This can be written as this can be written like this can be written like this. So if these three are in AP, then their reciprocals will be in HP. Right? So precisely these three terms are in HP. Okay? Just go for a recap if you are not clear for the first time. I assume them to be in AP, but I am not getting that. So what I am doing is, finally these three terms are in AP, that means these three terms are in AP, that means their reciprocals must be in HP, that is harmonic progressions. Right? Now see this question. If three positive numbers ABC are in GP, then log A, log B, log C are in. Okay, if ABC are in GP, then we can write B square is equal to AC. If I take logarithm of both the sides, what I'll be doing, log B square is equal to log AC. Right? Now log AC can be written as log A plus log C, and log B square can be written as 2 log B. So precisely log B is equal to log A plus log C by 2. That means log A plus log C by 2 is log B. That means log A, log B and log C, they are in AP. Okay? Simple. If ABC are in GP, then okay, what we can do is we can take the comfortable values of ABC. The values we have to take should be in GP only, and never ever take 1, because suppose A is 1 over here, right? So there is no calculation will be involved over here, right, because of A. Okay, so what I do is, instead of 1 I take 2, then 4 and then 8. So 2 2s are 4, 2s are 8. Now if 2, 4 and 8, they are in GP. Now what we can do is we just check the options one by one. So A, B square plus A square, and here on this side it is C, B square plus C square. Now we don't have to calculate, because C is much bigger than A, right? And here we are getting inside the bracket as A square, here we are having C square, and even C is greater than A. So this value can never be equal to this value, right? So don't have to check. Second one can be tried out. B square plus C square, that is B square is 16 and C square is 64 into this is A, that's 2, and here it is C, A square plus B square, that is 4 plus 16. So you can see it's 20 into 8, 160. Here it is 80 into 2, 160. So here we are getting the correct answer. So this is the correct choice. Okay. Now in a GP, the first term is A, second term is B, and the last term is C. Then sum of the series is. What you can do is, again you can assume the values of A, B and C. Right. Further I take suppose 2, 4 and 8. I assume there are just 3 terms in this GP. Okay. Now first term is A, second term is B, and the last term, that is 8. Now we have to find out the sum of the series. So precisely over here it is 8 plus 4, 12 and 2, 14. Now you just have to put up the values of A, B, C among the options and just see where do you get 14. Okay. So a square minus b, so 2 square minus 4, so that's 0, we cannot get. A square minus bc, 4, that will be 4 minus 8 fours are 32 upon a minus b 2, so we'll be getting here 15 only. It's minus 2. Okay, not 15, this minus 28 by minus 2, so we will be getting 14 over here. Okay, so this is the correct choice. And you don't have to go for the other options, because in the numerator over here you'll be getting the negative value, here also you'll be getting the negative value, and denominator is positive in both the cases. So no need to worry about it, no need to go for any sort of cross verification. Option B is correct. Okay, now see this. The sum of first three terms of a GP is to the sum of next three terms. Is this a common ratio of the GP? I assume the first term to be A, second term obviously it will be AR, where R is a common ratio, and third term will be AR square. So I take A as common, so 1 plus R square. This is the sum of first three terms. Then the next term will be R cube plus AR 4 plus AR 5. So I take AR square common. So I'm sorry, AR cube common, so 1 plus R square, and the ratio of these two is 125 by 27. Okay, A plus AR square, then AR cube plus AR 4 plus AR 5. You can cancel this. So 125 is 5 cube and this is 3 cube, so 1 upon R cube is equal to 5 by 3 whole cube. So 1 by R is equal to 5 by 3. That means R is equal to 3 by 5. Okay. The sum of first 10 terms of a GP is equal to 244 times the sum of first 5 terms. Okay, sum of first 10 terms of GP will be equal to, I assume the GP to be A plus AR square. So sum of first 10 terms will be A R raised to n minus 1 upon R minus 1, and this is sum of first 10 terms. I'll put n is equal to n. Okay, and that is equal to 244 times the sum of first 5 terms. Okay. Now solve it. R raised to 10 minus 1 is equal to 244 R raised to 5 minus 244. So precisely it is R raised to 10 minus 244 R raised to 5 plus 243 is equal to 0. So that's really simple. It's R raised to 5 minus 1 R raised to 5 minus 243 is equal to 0. So R raised to 5 is equal to 1. So R is equal to 1, or R raised to 5 is equal to 243. So R is equal to 3. Right now R cannot be 1, because if R is 1, then the entire GP will be having the same terms, AR square, everything will be same, right? So we have to eliminate this. That means R is equal to 3. Okay, I hope you are getting it. If second term of a GP is 2 and sum of its infinite terms is 8, then its first term is. Now sum of infinite terms is possible only when the ratio is less than 1. I suppose the GP to be AR square and so on. Now sum of infinite GP is A upon 1 minus R, right? So sum of its infinite terms is given to us as 8. And second term is AR, that is 2. Okay, so AR is equal to 2. Now since we have to find out the first term, what we can do is either we can go by option, or what you can do is instead of R you just put R is equal to 2 by A. So that is 2 by A. So if I take LCM, this will be the situation. So precisely it is A square minus 8A plus 16 is equal to 0. and it is actually a minus 4 whole square, right? So a is equal to 4, as simple as that. And if you wish to go by option, what you can do is s was a upon 1 minus r, and that was 8, and ar is equal to 2. So from options you can choose the value of a. Just suppose a is 2, then r will be 1. A is 2, if r is 1, r is 1 not possible because you will get denominator as 0. So this way you can discard. Similarly, you can go by other option. Otherwise, if you go manually, then also it will take not much time, right? Pretty simple problem. X is equal to this is up to infinity. Again, it's a geometric progression with common ratio as y. So an infinite geometric progression. So sum of this series, that is 1 plus y plus y square, will be a, that is 1 upon 1 minus r. Here r is y, right? Sum is given to us as x, that is first term upon 1 minus common ratio. First term is 1, common ratio is y, right? Now we have to find out the value of y. So that's pretty simple. X minus xy is equal to 1. So y, x you can take common. I'm sorry, we need to find out the value of y. So y is equal to x minus 1 upon x. Okay, so y is equal to x minus 1 upon x. I hope you are clear. Now see this, the sum to infinity. This is the sequence. Now you can see first, third term is similar, second, fourth is similar. That means we are that means this is actually the combination of two geometric progression. The first one is going like this, and the second one is going like this. Okay, so what we can do is from this entire sequence I take 2 as common. So I am left with 1. Now this is geometric progression, and sum we have to find out till infinity. So a upon 1 minus r will be the formula. Here a is 1 by 7. Common ratio is second term by first term. So that is actually 1 upon 7 square, right? So 1 minus 1 upon 7 square. So precisely it is 7 square minus 1, or I can say 48 by 7 square. So that is 7 by 48. Okay, plus here it is 2. Over here the first term will be 1 upon 7 square and 1 minus r. So again the common ratio is 1 by 7 square. So 1 minus 1 upon 7 square. So 7 square minus 1, that is 48 by 7 square. So that will be cancelled. So we'll be getting 2 by 48. So this is 7 by 48. This is 2 by 48. So precisely the sum is 9 by 48. So 3, 3 and 3, 16. Okay. Simple. I'm actually doing overwriting over here just to save space and time. Okay, so accordingly you can take the decision how you wish to go, right? And I would recommend you to just try to save your time and try to save the space. Okay. Sum of an infinite GP is 5 by 4 times the sum of all the odd terms. Now I assume the GP to be a, then a plus ar square plus ar cube and so on. Okay, now the GP is going till infinity. Now what will be the sum of this GP? That is a upon 1 minus r, right? Sum, and that is actually 5 by 4 times sum of all the odd terms. Now all the odd terms, that means first term, third term, fifth term and so on. Now again you will be getting an infinite GP. Okay, but in that case what will happen? The common ratio will not be r, but it will be r square, because if you divide ar square by a, the common ratio obtained will be r square. Okay, so first term will still be a, but the common ratio will be r square. Okay, now here a and a is cancelled, and 1 minus r square can be written as 1 minus r and 1 plus r. 1 minus r and 1 minus r is cancelled. So here 4 plus 4r is equal to 5, right? 4 into 1 plus r is 5. So 4 plus 4r is 5. So 4r is equal to 1. R is equal to 1 by 4. Okay. If the AM between the roots of a quadratic equation is 8 and GM is 5, then the equation is. Now this is good question, but very simple. I assume, just listen to me carefully, I assume the roots of the quadratic equation is a and roots are a and b. So the quadratic equation will be x minus a, x minus b is equal to 0. So precisely it is this, right? Now a and b are roots. Arithmetic mean is 8, right? AM between the roots is 8. That means a plus b by 2 is 8. That means a plus b is equal to 16. Geometric mean is 5. That means a root AB is equal to 5. That means AB is equal to 25, right? So AB and a plus b we can put over here. So we'll be able to get the equation. So a plus b must be 16 and ab must be 25. So precisely your equation is x square minus 16x plus 25. Pretty simple. Looks to be tedious, but it's really simple. I hope you are getting it. So friends, in the next session we'll be taking more problems based on arithmetic, geometric and harmonic progression. Do revise this session and the previous ones. I'll see you in the next session once again. Bye bye.